I wanted to go over there's a proof in lesson 11.6. It's the proof of Theorem 52, and Theorem 52 says if two non-vertical lines are parallel, their slopes are equal. And so this is on page 466, and it's numbers 52 through 59. All right, so I tried to sketch it up here just for reference, the little sketch, but you may need to look at page 466 to follow along with this because it's really tight in here, but you can refer to the figure on page 466 above number 52. So what we're trying to do is we're trying to prove that if two non-vertical lines, such as L1 and L2, are parallel, their slopes are equal. So they're telling us our given information here is L1 and L2 are parallel. So they're going to ask us some questions here, and we're going to try to give the reasons for them. So here's the drawing. Let's start with number 52. Now, part of this, they're expecting you to go back to some previous problems you've done in this section. So this is building on some of the things you did earlier in 11.6. It says, what is the slope of L1? Well, if you look at the slope of L1, the slope is, you could look at it a couple of ways. You could look at the rise over the run is one way to look at it. So the rise, if you're going from B to A, would be AC over BC, the run. But that's one way to look at it. If you notice, they do that on step 59. That's not what they want here. What they want here is for us to make the connection from earlier in the book that the slope of L1 is the tangent of angle 1. So really what we're looking for here is not this, though this is true. You'll see this pop up down on number 59 if you look. But what they really want, I'll write in red, the slope of line 1 is the tangent of angle 1. So we're using trig to prove some things about slope here. Now, 53 says, what is the slope of L2? The slope of L2 then would be, if we follow along this same thought, I could, again, and you'll notice down on the bottom, that they write the slope of line 2 is the rise DF over the run EF. But again, that's not what they want here. They'll bring that up on step 59. What they really want here is for us to notice that the slope is the tangent of angle 2. 54 says, why is angle 1 equal to angle 2? Well, since the tangent of angle 1 is, since these are parallel lines, we could look at it as parallel lines cut by a transversal. So let me draw the, highlight the parallel lines. The two green lines are the parallel lines. The transversal could be that axis there. So why would angle 1 is equal to angle 2? And that's because they are corresponding angles. Corresponding angles are congruent. Okay. Number 55, it's hard to read that yellow, I'm sorry. Why is triangle ABC similar to triangle DEF? Well, if angle 1 and 2 are congruent from step 54, by angle, they're similar because we have the two right angles in the triangles that are similar, and then we just showed that angle 1 and 2 angles, the right angles are congruent, and then angle 1 and angle 2 are congruent because they are corresponding angles if we look at those parallel lines cut by a transversal. Okay, step 56 says, why is AC over DF equal to BC over EF? And so they want us to give the reason why here. If I look at the reason why here, AC over BC, I got off on the wrong line there. No, I didn't. They're matching up sides here on, since these two triangles are proportional, let me use purple here to kind of show you what they're doing here. This AC matches up with DF since they're similar, the way that, and I'll do a light yellow here, the way that BC matches up with EF. So you can kind of tell I wrote over that yellow with another yellow. So that is because sides of the reason here would be sides of similar triangles. I'll put SIM for similar triangles are proportional. So we're just making that proportion that we know is true because they are similar figures. You may need to pause the video at this point because I'm going to erase this so I have room to continue this and not have to redraw the drawing there. Okay, so we saw that on 56 that we set the corresponding sides, we made proportions out of them, and so we know that that those are proportional. So we have that statement from 56, AC over DF equal BC over EF. What they're going to do now is rearrange these to show that the slopes are parallel. Actually, I kind of misstated something. I'm kind of thinking about this proof as I go through it. On 52 and 53, they did want us to put that the slope of L1 was AC over BC, the rise over the run, and the slope of L2 was DF over EF, its rise over run. So they did want that. It's also true that the tangents are the same. That is that both of those statements are true, but they actually wanted the fractions, now that I think about it, because that's where they're going with this as I look at this proof. We have this statement from 56 that was true because those proportions we make out of similar triangles are true. Now if you look at 57, and let me write that down, what they're going to do is cross multiply here if you look. You get AC times EF is equal to BC times DF. I'll do that one in a different color just so you can see where things are coming from. And all that reason was there is basically multiplication. We cross multiplied here. That's all it is here. So all they're doing now is taking this proportional statement and they're doing some algebraic things to these segments. So then what you see now on 58 is y is AC divided by BC equal to DF divided by EF. All they did was they divided BC out of both sides, so it canceled out on the right and it shows up on the left. And then they divided both sides by EF, so it canceled out on the left and it shows up on the right. So the reason that you'd give for that is just division. That's simply all they did. They did two different division steps there, and they just wrote the result down. And so 59, if you look, isn't AC over BC what we had on 52 that was the slope of L1? So what we have here is the slope, that is the slope of L1 on the left, and on the right we have the slope of L2. So they write that M1, slope of line 1, is equal to the slope of line 2. And what we're doing here is this is just substitution from number 52 and 53. If you go back up to those lines on 52 and 53, you'll see that we had said that the slope of L1 was AC over BC and the slope of L2 was DF over EF. And I misstated at the beginning that what we were really interested in was the tangent, and we weren't. We really actually needed to look at those fractions. I kind of realized as I went through the proof that we didn't. That's really what we were interested in, not the tangents. So you kind of have to disregard what I said earlier. So anyway, what we have here is now we have proved the slopes are the same. If we have two parallel lines, we've proved the slopes are the same. And so there's another proof for you of Theorem 52.